Hi friends, this is Hemadri. I am working as assistant professor in the Department of Mechanical Engineering in RMK College of Engineering and Technology. So today I am going to discuss about in engineering metallurgy ion carbon equilibrium diagram. So first we will see the ion, how the ion it is changing with respect to various temperatures, what is the microstructure. So first we will take the cooling curve temperature with respect to the time. So at this temperature 1539 degrees centigrade, above this temperature, so entire ion it will be available in liquid form. So slowly we are cooling. So at this temperature 1400 degrees centigrade, so the ion it will be available in delta form, that is called BCC structure, body centered cubic structure. So why it is changing means, so that is called ion, same ion it will be available in different structures at various temperature. We can call this as a allotropy of the particular metal. So allotropy means one metal it is available in various structures. We can call this as a allotropy. So now I am slowly cooling. Again at this temperature, once it will cross this 1400 at 910 degrees centigrade, between this range ion it will be converted to gamma form and it is in FCC structure. So the crystal structure also it is changing. So and it is in non-magnetic. So again we are cooling at this temperature 770 degrees centigrade. So entire ion it will be converted into alpha and again it is changing to BCC structure. So still we are reducing, finally it is alpha and BCC structure it is in magnetic form. So like this the ion it is changing the crystal structures at various temperatures. So why means, during the slow cooling in the crystal structure the atoms it will be changing the positions, and then due to this dislocation mechanism, and then the atoms will move and it will be occupy the various positions. So then the crystal structure will change. So like this it will happen. Now we will see various crystal micro constituents of ion carbon alloy system. So first one is ferrite. Ferrite means it will be available at, we can call this as a alpha. It is in BCC structure. So at 0.025% carbon, entirely this is the solubility limit, and then slowly it will decrease, and 0.008 percentage it will percentage of carbon it will reduce from 0.025 to 0.008 percentage. So what are all the properties of this materials means, tensile strength is very high, 274 megapascals, elongation to failure is 40%, hardness is 90%, 90 HRB. So the structure is looking like this microstructure. And the austenite, so austenite it is available in FCC form with respect to 1130 degrees centigrade. And then cementite, next one is the C here, the cementite structure is looking like this. So the it is in some nodular structure, and then it is in black, at it will be having the 6.67 percentage of carbon. So we can call this as ion carbide. So it is very hard, and then the tensile strength also low strength compared to the previous one, but it is having the good compressive strength. So the structure is orthorhombic crystal structure. And then next one is leadiburate. So here leadiburate mixture, so it is like some plate slightly mixture. So it is having the 4.3 percentage of carbon, it is forming at 1130 degrees centigrade. So in ion carbon phase diagram, so all these microstructures it will available. Perlite. So perlite means ferrite plus cementite, we can call it as a perlite mixture. So the structure is looking like this. Next one is bainite. So bainite means, so once it will, the austenite, it will transform to lower, we are reducing the temperature, it will be converted to bainite structure. Next one is martensite. So the structure is looking like this. So it is like needle like structure. And truecite, it is like nodular structure. So now we will see the ion carbon equilibrium diagram. So this diagram, it will be drawn between temperature versus percentage of composition with respect to the ion carbide. So or we can call it as a ion carbon. So 0 to 6.7 percentage of carbon, we are having this in x-axis, and y-axis we are having up to 1600 degrees. So now 0 to 2 percentage of carbon, we can call it as a steels. Again here 0 to 0.76 percentage of carbon, we can call it as a hypoeutectoid steels, and 0.76 to 2 percentage carbon, we can call it as a hypereutectoid steels. And then more than 2 percentage of carbon, we can call it as a cast ions, up to 6.7 percentage of carbon. So here 2 to 4.3 percentage, we can call it as a hypoeutectic cast ions. On right side we are having the hypereutectic cast ions. So now in ion carbon phase diagram, we are having the majorly three reactions. So first one is at this temperature, first we will see the slowly we are cooling this ion carbon with respect to temperature at 1538 degrees centigrade. More than this, entirely it will be converted into liquid phase. Then slowly we are cooling. So first it will form this delta phase. Delta means delta ion at this temperature. And then here liquid also will be there. So here liquid plus delta, it will react isothermally and it will give the gamma. We can call this as a peritectic reaction. So one solid plus one liquid, it will react, it will give another solid. This reaction is peritectic reaction. So this reaction will happen at 1493 degrees centigrade. So coming to this side, so here liquid plus gamma is there, and entire liquid, it will be converted at 1147 degrees centigrade into gamma plus Fe3C. We can call this as a leadiburite mixture. So that is called austenite plus cementite. Those mixture, we can call it as a leadiburite mixture. So this reaction is eutectic reaction, and still we are slowly cooling again at this temperature. So entire one solid, it will be converted into two new solids. So that is called gamma, it is giving the alpha plus Fe3C. So ferrite plus Fe3C, we can call it as a perlite mixture. So this reaction, we can call it as a eutectoid reaction. So what is the temperature means 727 degrees centigrade. So this is the critical temperature, lower critical temperature of steel. So in ion carbon diagram, totally three reactions we have seen. And then see left side we are having the only alpha. So here it is alpha plus gamma, and then gamma, it will be give the alpha plus Fe3C. So bottom of this region entirely it is perlite mixture. So this is the major thing in ion carbon phase diagram. So here slow cooling of steel, that is called carbon content less than 0.76 percentage. So what will happen? So here see here at this temperature so above this point entirely it is gamma, slowly we are cooling. So it will form small nucleus of this cementite. Still we are cooling, the cementite grains, it will increase. So once it will cross this line, eutectoid line, so we are having the cementite grains plus eutectic mixture that is called eutectoid mixture. We can call it as a alpha plus Fe3C. So here the structure, it is changing from FCC to BCC structure. So carbon content exactly at 0.76, that is called eutectoid composition. So how the structure is changing from gamma to eutectoid mixture. So see the microstructure difference. And carbon content greater than 0.76 percentage, that is called hypereutectoid composition. So here in hypereutectoid, same that alpha plus Fe3C, that is called perlite mixture will form, but plus cementite grains are more, that is called right side of iron carbide. So there cementite grains will form. So that is the only difference between hypereutectic steels. So this is about iron carbon phase diagram. So finally I am summarizing. So today we have seen about iron carbon phase diagram and the various micro constituents of iron carbon alloy system. So and then we have seen the various reactions in the iron carbon system. Thank you.